I'm John. I'll be giving the talk today. This wound up being actually a really fun workup. I think it's the most exciting thing I've ever done with software. So if y'all enjoy the talk half as much as I enjoyed preparing for it, you're in for a treat. So this talk is about SME interviews. I'll go into more details as we go down the line. Okay, so this is what we're going to talk about. So I developed a product called SME Interviews. It was intended to help technical writers do better SME interviews. It sucked. I'm going to explain why. Uh, then we're going to go into some AI and machine learning concepts. So it'll help you like understand uh, the the meat of my presentation. And then we're going to deep dive into an actual machine learning solution that I wrote to help deal with subject matter expert interviews. So this is the first reason why SME interviews sucks. Who's this guy? That's me. I'm not really a technical writer, but I have been doing technical writing in all of the positions that I've held for the last 10 years. I've documented like product and IT systems. But basically, writing documentation has helped me be successful in all the roles that I've held. It's actually the reason why I'm so passionate about technical writing and why I have developed several products focused on technical writers is because I've done like 2 different career transitions in the last 10 years, and both of those were powered by technical documentation that I read online. So I was able to get into IT because there's a lot of online documentation about how to do virtualization, networking, et cetera, on the internet, and I consume that stuff. I transitioned to IT in 2015. Similarly, there's a lot of technical documentation on how to write code, which I consumed and got my first job as a software engineer in 2022. So I've been through 2 successful career changes thanks to technical documentation published on the internet. So super enthusiastic about helping technical writers do a better job at their trade. Not really an entrepreneur, but I do own a successful cleaning company, and I've failed to start a food truck, failed to start a building automation company, a data broker, a company that sells wooden bow ties, a couple of companies trying to sell software for technical writers. But y'all don't worry, I'm going to get a hit before too long here. I'm not really an engineer, but I have shipped 2 full stack products into production, 2 into staging. I got another one in development. Definitely a dad. I actually like my daughter better than I like doing any of this stuff anymore. So I've shipped 2 products for technical writers. The first one was called User Docs. It was an application that automatically collected screenshots for technical documentation from web apps, and it was a full bore bust. I failed to get any traction on it, failed to get any customers, but it was the first application that I got out the door, and I learned an incredible amount from it, both technically and from a business and marketing perspective. And it's actually still out there. It's open sourced on a GitHub. If you're ever interested in giving it a whirl, you go for it. I have some stuff to fix on my production instance, but you know, if you're really interested, let me know. And then the second one, which is more relevant to the topic of the talk, is SME interviews. So I actually shipped a little question and answer application for conducting SME interviews. It was a very simple application. Basically, you could go in and make a list of questions. An interviewer could come in and answer those questions, and you could get a little chat thread for every question and answer pair. So it wasn't bad, but it didn't solve the problem. So did I miss a slide somewhere? Hang on. Okay. Here's why it sucked. I built this product based on my own experiences from technical writing. And I've never actually been a full bore technical writer. So I always knew the domain. Like it, you know, it was with the building automation company. I made a lot of effort to learn that product really well, like the back of my hand, and write documentation about it. So I didn't need to have long, in-depth conversations with people. I had a couple of very pointy questions that I needed to answer so that I could churn out documentation, but I knew the domain, and I could always learn things very quickly. And it's the same with the other products I documented. I got very, very familiar with those products and I knew a lot about them. So the only questions that I had were small and pointy. So a QA app makes perfect sense for somebody who's in that position. But in my current job, we're, I'm a software engineer, and we have a vast number of systems stood up in this company. And it is not feasible from a time nor a brain space perspective for me to go and learn all of those systems really quickly. My only option is to get with the engineers who created it and pick their brains for long periods of time, and then come away with, these long, very technical, very in-depth, very dense recordings of conversations that I then have to turn into documentation. So SME interviews sucks because I didn't really understand the problem. And based on the current work that I'm doing as a technical writer, I'm starting to understand the problem. So what is the actual problem? So like I said, I'm having these long, complicated conversations with the tech leads and developers who have stood up these systems. And I come away from those I always record these things because I know better. And then I run them through otter.ai or something similar to create a transcript. So I walk away with an hour of video and many, many pages of text that it's not copy and pastable. It's very difficult to ingest. I have to synthesize all that into some sort of, knowledge and write that up in documents. And I don't know what the process looks like for more experienced technical writers, but for me, it means I just sit down with a markdown window and this video and this transcript and go over it over and over and over again until I have caught everything. And 1 hour of video content is taking me hours or tens of hours to consume and turn into something reasonable that anybody in their right mind would give a crap about. And so I've found it very frustrating to conduct these interviews and then get the information and turn it into knowledge and turn that into a document. But as it turns out, natural language processing and artificial intelligence are extremely well suited for this problem. And so actually, what I did to prepare for this talk, partly because I'm in the middle of shipping another AI product right now, is I used these SME interviews as a way for me to learn these concepts. And I stood up a little application that handles an interview transcript. So before I get into the real meat of the thing that I created to show at this talk, I want to do a little bit of basics about artificial intelligence so that when I jump in and start showing you the code, you're going to know what I'm talking about. And this may be very helpful considering the way the world is going right now. Also, I am going to drink some coffee for 2 reasons, because it's warning for me because I talk real fast. I figure y'all need a break. So the most fundamental concept behind a lot of modern artificial intelligence systems is called a neural network. And a neural network is basically like a digital implementation of how your brain works. You have a number of nodes. Each node is connected to every other node in the next layer. Each node is weighted. So it has like, they're basically adders. It's taking all of the inputs from the last layer, multiplying those inputs by a weight, and adding them all together. So these neurons get a weight that's associated with each one of these inputs. And then the inputs have a threshold. So when the input into the neuron is exceeded, that neuron will fire. And these weights, basically what will happen is that you'll feed this neural network a set of inputs, and it will produce an output, and then you will tell the network whether that output was correct for the given input. If it is wrong, it will readjust its weights and try again. So working with artificial intelligence is very different, or working with neural networks is very different from writing regular code. When you write regular code, you go if and loop, insert some stuff into a database, and you get the answer out of the other end. In AI and machine learning, you basically have these huge, nowadays you have huge networks of, neural networks that are all talking to each other and performing different functions in different layers. You're feeding it some input, and then it's adjusting weights and producing an output. So you don't get the same answer all the time, but you can feed it a bunch of new input that it's never seen before, and it will produce a reasonable output. So I actually don't want to go to that one next. I'm going to go to this one next. So as with most things in computers, though, it needs numbers. You can't just feed a neural network a huge splat of text because it doesn't accurately represent the semantics of the text to the model. So how are we going to get from large whacks of text and or images into numbers that we can throw at a model? And the answer is vector embeddings. So here is the simplest example that you could ever come up with. This is a two-dimensional vector space that represents the size and the colorfulness of animals. So a 001,001 is a tiny gray mouse, and a 0.9,0.9 is a big yellow giraffe. And what would that be? A 0.9 is a crab, and a 0.9, 0.01 is a rhinoceros, right? Less colorful animals on the left, more colorful animals on the right. Smaller animals on the bottom, bigger animals on top. So you can reasonably get, all of the animals in the world and label them as a vector representation of their size and colorfulness. And you can train a network by feeding it vectors and expecting it to say giraffe or mouse or elephant. You can represent anything as a vector embedding. And when you get into the modern vector systems, they have 768 dimensions. So it's a huge, complicated vector space. When we're representing text and images and stuff like that, it's like, I think it's 768 or maybe 1300 dimension vector space that you're using to represent text. So this is how all these different models are able to take large bodies of text or images and feed them into a model and get reasonable outputs. So that should be enough to lead us into large language models like GPT or Falcon or Llama or any of the stuff that's been hitting the news lately. Y'all, They train these things on Mad Libs. I am not joking. I'll give you sort of a very brief description of the difference between supervised training and unsupervised training. And it's really simple. It just basically means there's a human there labeling the data, or there's not a human there labeling the data. So in supervised training, you're going to take people and they're going to come up with the vectors of the animals. They're going to be like a rhino is 0.01.9. That's rhino. And they're going to feed this big data set into the model, and then the model is going to do these predictions. In unsupervised training, there is no human. So check it out. Here is the innovation that allowed machine learning experts to create these large language models. They would take a large corpus of text, they would remove words from the text, they would feed that text to the model, and they would expect the model to figure out what word they took out. Literally Mad Libs. So they could go to a Wikipedia article or something that has a complete body of text. They could blur out some words, feed it to the model, and the model would predict which word was missing. So all these models do is take the prompt and the current output and predict the next word. That's all they do, is predict the next word. And I don't know how it is on y'all's side of the pond, but it's the rise of the machines around here. Things are going crazy over this, which I find kind of hilarious. Okay, so the next thing that's really important here is called cosine similarity. Cosine similarity is a reasonably fast way to measure the difference of angle between two vectors. And this is used, like, for example, if you watch a video on YouTube and you get to the end of the video and it recommends you several videos, how is it doing that? I'll tell you how. It takes the video you just watched and it converts it to a vector, and it has converted all of the other videos in its database into a vector. And then it puts all of those vectors into a vector database, and then it does a cosine similarity search on that vector database, which returns the most similar videos, and those are the ones that are presented to you at the end of your video. That's what cosine similarity is all about. It's about taking these numerical representations of abstract media and being able to figure out which ones are the most similar. Well, at least for this part of the stuff. So these are used in recommendation systems. If you go and get a Chat GPT extension that reads your PDF or whatever, it's converting all of that text data into vectors and stuffing it in a vector database somewhere. And then when you ask Chat GPT questions about your PDF, it's querying that vector database, returning the content that's most similar, stuffing it in the prompt with your question, and answering the question with the necessary context. There are a number of very interesting pieces of technology that do this. Most of them are based on a technology called FAISS, which was actually developed by Facebook. And I think it's Facebook Artificial Intelligence Similarity Search, but I'm not sure about that. That technology wrapped into some commercial products like Pinecone and Milvus, and there are some open source options out there. There's a Postgres extension. It's pretty interesting stuff. Super, super powerful. I'm going to take a bit of a digression here and say that I really think that natural language processing is one of the biggest and most powerful tools in the modern technical writer's toolbox, and sort of learning how this technology works can be very beneficial for writers, because having the ability to take these massive walls of text that we produce and turn it into something numerical that's queryable is a big deal. All right, let's see if I can make this thing continue to work. Okay, so let me describe the example. The next thing I'm going to do is to bring up the actual example, and we're going to go through the code and a data set that I prepared for this talk. So, like I said, I'm starting all these things with a transcript that I get out of Otter. So my little application will go to this text file and get the data out. And then it'll chunk it. Basically, I just take the default, whatever comes from the transcription software. In Otter, it breaks it up by like this person said this stuff, and then that person said this stuff. And so I just keep the chunks that come from the transcript. Then the next thing I do is I go off to, it's an OpenAI API called ADA, which converts text into embeddings. So I rip through all of the text, I go to OpenAI, and I get the embeddings. And then I put those embeddings into a vector database. So I now have the transcript of the interview, all converted to vectors, all stored in a database. So now for the fun part. So now I go through and I build a cosine similarity matrix. So basically what the cosine similarity matrix does is it compares every sentence or every chunk of text to every other chunk of text that it found in that transcript. And it runs cosine similarity matrix so it knows how different every statement is from every other statement. Then I put this matrix, it's called the Louvain community algorithm. I have no idea how it works, but what it does is it returns groupings of those chunks. So it groups together the most similar chunks of text according to their cosine similarity in a list. So then the next thing I do is I group all those together. So I just assume if this algorithm said it's about the same topic, then it is. Then I will send that in, like all the text that it grouped together, off to OpenAI, and it writes me a summary and it writes me a title of that topic. So basically what I'm doing here is I'm taking the interview transcript and I am figuring out what it is about. And I can send a resolution to this algorithm. So if I want 10 topics, it'll give me 10 topics. If I want 30 topics, it'll give me 30 topics. So what we have now is we have vector embeddings for all of our text chunks, and we have summaries and titles for all of our topics, which is a really good first step into planning an outline for a document, sorry. So what do we do next? Well, we just ask the model to build us an outline from those topics, and it does. And it's not super good. So in my first pass here, I just took the outline that I was given back by the model, and I just sent it along and had it write documentation based on that outline. So that tells me, you know, first, you kind of need to step in and mark things up if you want to get a good result. Either that or my outline prompt and strategy needs to be upgraded if we wanted this to be automated. But I have an opinion here, which is that this is really intended as assistive technology, not automated technology. So I never intended when I got to the beginning of this thing that you could just mash the button and get a reasonable article out at the end. I actually don't think that the technology is that far along. So I think that this is more about understanding the content of the conversation and having some help to ingest the knowledge that came from it, plan your document, and get a reasonable first draft. So we have this list of topics. You can intervene at any point. You can go in there and say, you know, this is bullcrap. These are the actual topics, and edit that list. And the next thing we do is we send this list of topics to GPT-3 and we ask it for an outline. GPT-3 returns an outline, which you should then edit. And once you're done with the outline, basically we send the outline back in, and what my algorithm will do is, for each outline topic, I will query the vector database and I will get back the most related embeddings. Then I will send the prompt, which is basically the outline heading, and the content that we received from the vector database, and it will write that segment of documentation. So if you have 20 headings in your outline, this thing will, for each of those topics, it will go and get the relevant content, and then it will ask GPT-3 to write that section of content. And then I just slap all that together and render it into a markdown document, and I have a rough draft. So I've now used this approach twice. I used it on the initial transcript that I had gotten about this, like that I actually wrote the application on. And then a couple of days ago, my team lead gave a talk about pricing. And I took that talk, and it took me about 30 minutes with the product manager to brush up the outline and produce a rough draft of a in-depth technical conversation. And I was very proud of that. And the results were not terrible. They were actually fairly accurate and represented what we had talked about. So now I'm going to show you the code and actually time check, because I have no idea how long I've been talking. So because I don't want to leak any intellectual property here, I used ChatGPT to write me a conversation about BERT, which is a modern encoder that produces vector embeddings from text, between a cowboy and a pirate, obviously. It's not as long as the data sets that I've used in the wild. It's also in written language, not spoken, so it's a little cleaner. But trust me, folks, this works on real data sets. I've done it in the wild. I just can't show it because it's not my intellectual property. All right. So, the first thing we do here is we're going to chunk out this transcript, and it's going to just return us a list of strings, one for each statement made in the conversation. Then the next thing we'll do is we will convert all of these strings into vectors, and we'll group them by topic. And I'm just going to run this stuff as we talk through it. And a lot of this stuff actually takes a long time to run because it's very computationally expensive. And we'll just hope that this actually works. So you can kind of see what it does. It just returns this list of integers representing which topic is which. And I'm going to run, let's see here. Then we we basically clear everything out of our vector database and send all of those vectors back into the vector database. Now, before I run this, I'm actually going to go through and show you and I may not, we'll just see. Anyway, these are the titles of all the topics that this thing thinks we talked about. And the way that we're figuring this out, and I'll probably go over here and show you the prompt, but basically what we do is we take this list of topics that we got, and we splice it together with the list of strings that we had before, and then we group them according to that topic ID. And then we just join all that together to get a list of summaries, which that's basically all the content in that topic grouped together. Then we we feed that into a prompt. And this is similar to what you would be doing if you get on and work with ChatGPT, right? Give the following text an informative summary, then write a 75 to 100 word summary of the following text. And we got an example. It's not rocket science. And this is what we get at the end. BERT, a language model based on the transformer architecture. Here's all the text that we found from the conversation that got grouped into that topic. The token count, which here's another basic concept. A token is a piece of semantic. It's like a piece of semantic meaning from text. So it's usually a word, but it's not always a word. There's usually about 75%. If there's 100 tokens, that'll be 75 words. So tokens will represent words or parts of words or punctuation. It's basically anything that has semantic meaning from text. And almost everything is tokenized before it is fed into a large language model. And basically all of these tokens can be represented as integers, which are then encoded into embeddings. And I got the token count out of this because I was pretty interested in knowing how much of the conversation was occupied by this topic, because I actually don't have any other way to, without going through and reading this, understanding how important any topic is related to any other topic. And I think maybe the best way to do that is with token count. So that's why I kept it. So title, BERT, a language model based on the transformer architecture. Summary, Jane and Philip discuss BERT, a language model based on a transformer architecture, which is a type of neural network. BERT is able to understand and generate human-like text and is unique in its ability to understand the content of words and sentences due to its pre-training on diverse data. So there are, and I specified how many. Let me see. 16. There are 16 topics in here. So imagine taking a long technical conversation with someone that you just had and being able to, within minutes, get a synthesis of all of the things that you talked about in that conversation. This is super powerful because usually it takes me an hour or two to get here because I have to sit down. Usually the process I go through is I'll sit down with the recording and the transcript and I'll tune up the transcript. And that's always my first pass, is to make the transcript accurate and to sort of reinforce all of the stuff that we just talked about. But now you can just use this to do that in minutes and get a pretty good idea of what you discussed. You still have to clean up the transcript, but you can also delegate that, which is definitely going to be my approach. So we'll just run that while we're sitting here, just so I can prove that my stuff works, more to myself than to y'all. Okay, so the next thing we'll do, we're just going to blind, and this is probably why the outline doesn't turn out very well, but we're going to blind feed those 10 topics into the model and ask it to generate us an outline. So act as a technical writer. Develop an outline for an informative technical article about the topics listed below. Topics with higher topic count are more important, should be listed as primary topics in the outline. Blah, 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 blah. And I actually had a friend help me out with some of this stuff to help better instruct the model. Then we feed it all the topics and we feed it the summaries as well. That way it at least has some context about what it's writing the outline. And then for my own ease of use, I just ask it to generate me the outline in JSON format so I can then immediately convert that into a nice in-memory structure. So it produces something like this. And it actually breaks one of my commands here, and it frequently does just copy and paste the topics. So BERT, a language model based on transformer architecture, pre-training with BERT, etc. And this one is actually not hierarchical at all. But that's fine for this example. So this is an example outline that the thing generates. And I modify it because if you can't just let this thing go off in the weeds if you want a good result. You have to intervene. You have to intervene probably starting at the topics and continuing to intervene at the outline. But it will get you good results if you hold its hand a little bit. So this is just a sample. This is the manual outline I produced with the product manager about the pricing conversation. So, and here is the last part. This is the really meaty part. This is where we are going to actually generate the document from the outline. And I'm going to start running this. We'll also give you guys, this takes a while. This is like a 5-minute process. So same deal. We're going to come up with a prompt. You're an expert technical writer. Your job is to write precise technical content from informal text. Write around this many long content for a technical document about whatever the title is. Use the information below to inform your content. And this is where we stuff all the stuff from the vector database. I did a separate one for definitions because I wanted to be able to write definitions in addition to technical content. One of the things I envision here is like, is to feed the model a task that says, go through and find any words that you don't know what they are and extract them out. And then a second task that writes definitions for those words based on the content of the talk. And then those definitions would live as part of the technical content. The other thing I did in here that's really interesting is I gave this a, on any of these outline things in JSON, you can feed it something that says diagram true, and it will write a plant UML diagram about that topic. And it does a mighty fine. If you're not familiar with plant UML, by the way, it's a diagramming language. So you write your diagrams, and then plant UML will render them into images. And it's really, really sharp. If you've never looked at it, I highly recommend you do. But ChatGPT can write plant UML diagrams. So I had it write me some plant UML diagrams, and they look pretty good. I was not complaining about it. So yeah, it basically does what I had on that slide. It will go out for every outline topic. It will go and fetch information from the vector database, and it will feed it back into this prompt along with the instructions. And that's why it takes so long. So then I render it into Markdown. This one, I actually took this out. I was adding an introduction that was just like a summary of the entire document, but I didn't like it that well, so I got rid of it. But we basically just render this, render all of that stuff into Markdown. And let's see if I had one already. I can't remember. I don't think so. I may not have my Markdown previewer on here. It looks like I don't. So I can't show it to you all pretty, but I will do this at least. Exploring BERT, a revolutionary language model. So it's writing stuff I know that it's fairly accurate because I've read the content of the conversation. It does a pretty good job of producing accurate content because at every step, it's being fed context from the conversation that we pulled out using this vector database query. And I really think this is necessary for producing technical content. I don't think that you can reliably ask a model to produce large swaths of technical content because anyway, here's another fact. So here's one of the limitations of large language models is they have a context window, which means that they can only handle, in GPT's case, 4,096 tokens. So that means that the combination of your instructions, the content that you feed it, and the content it produces has to be less than 4,096 tokens. So a lot of the backflips that we're doing in terms of artificial intelligence code is figuring out how to get something reasonable into that 4,096 token context window and still get good results. And when it comes to technical content, you need a ton of context information for a small amount of content that you want to produce. So I think that this is a solid approach for getting accurate results out of these models, is writing on a small topic or even paragraph by paragraph basis. So yeah, this is a way to cut down potentially hours and potentially tens of hours of work ingesting, synthesizing, and writing technical content about different topics. It's a huge shortcut. Also, and I added this one. I just added this one the other night because I wanted something to kick around with you guys. Hang on, let me get this thing to the end. So it made it all the way to the end, right? And generated this document. Probably took 4 or 5 minutes while I was sitting here yapping. So now I'm at the end of the talk. Okay, so here was the question I asked it was explain an attention weight. Attention weights are numerical values that indicate how much attention a model should pay to certain parts of the text. They're used by BERT self, blah, 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 blah. So it's gone into this content from the conversation and it's able to answer topics. So like, think about this. I have a thing, it can tell me what the conversation was about. It can help me author an outline. It can help me author a rough draft, and it can sit there and answer questions about the topic while I'm working on the documentation. Like, this is hugely valuable from conversations that I have about people so that I can produce reasonable documentation from it. And so that's really the end of my talk.